Go ahead and tell you a little bit about myself. My name is Jeff Lyon. I started into DDoS mitigation in about 1999. Been running Black Lotus ever since. We're a DDoS mitigation provider on the service side and have actually dabbled into the appliance market a little bit. My purpose here is not to talk about Black Lotus, but is to give everyone here in the room a real technical discussion about how to protect yourself from DDoS attacks. So the question here is, what can the small, medium web hosts do to protect themselves? Most DDoS talks that I attend or that I hear of are why a certain appliance is good, or why you need this cloud security service, or why you need to use my clean pipe service. And that's not why we're here today. We're going to go ahead and open up with opening remarks from the panelists, and we're going to go straight into a very educational, technical discussion. My background, went ahead and stated that in the first bullet there. When the first US CERT advisories came out in '99, that's basically when I jumped into the business and started up Black Lotus. DDoS mitigation has really been a huge product probably ever since about 2007. So there was that early era from say 99 to 2007 where many of us were in the market, but it wasn't a huge business. Now that the attacks are growing exponentially, DDoS mitigation is a real threat. And it's time that hosting providers figure out how they're going to protect themselves and how to protect their customers so that they remain relevant in the market. Carlos, your opening remarks?
Sure. Good morning, good afternoon, guys. Carlos Morales from Arbor Networks. For those of you who may not be familiar with Arbor, we're somewhat of a dominant player within the DDoS space, just providing systems and solutions, mostly in the service provider space where DDoS is really prominent over the last few years, and then moving to the hosting space down to the enterprise and whatnot over the years. I've been with Arbor 9 years, so right at the onset of where DDoS started making its way into the market was sort of looked at like worms and some other smaller type threats, all the way to the far more prominent anonymous-based attacks that are happening today. So my background is technical. I was a sales engineer, moved up, and I currently run the global sales engineering group for Arbor. So I have a lot of experience in deploying solutions on the DDoS front and look forward to sharing with you guys.
Thank you, Carlos. And we're still looking for Matt Prince. I hear that he's on his way, so we'll go ahead and give him a seat once he arrives. Dr. Richard Zhao, NSFocus, your opening comments?
Yeah, I'm the Chief Strategy Officer of NSFocus. For some of the audience, NSFocus might be a new face, but we are a veteran at Asia Pacific. We start to provide anti-DDoS product to the top carrier and the internet operators from 2002. As the Chief Strategy Officer, I manage the secure labs of NSFocus and the research team and strategy product planning for the company. So it's my great pleasure to be part of the panel.
Thank you, Doctor. And Matt Mavi, go ahead and speak on behalf of Staminus Communications in place of Kevin Hatfield.
Our company, Staminus, we actually started in 1998. We didn't begin by offering DDoS mitigation, but we did succumb to DDoS attacks before anybody else really knew what they were. So we had to come up with a homegrown solution because nobody else was really in the market. In 1998, nobody even understood DDoS attacks. So we built our own solution, and since then we've been in the market providing mitigation services to companies and providing hosting services as well. So we're a dedicated server shop, cloud hosting shop that provides mitigation on top of those, as well as remote DDoS mitigation using various tactics and techniques as well. We're also diving into appliances.
Thank you, Matt. All right, the first question is for you, Matt, in place of Kevin Hatfield. This question came from Derek Morris at Pingzine via Facebook. Is it possible to have a network 100% safe from DDoS attacks? And what are some of the flaws and issues that allow these attacks?
Kind of. So I can theoretically say yes, and you can technically drop off a server from the face of the internet, and it'll be 100% protected, but at some point or another, you're always going to have some new technique that can bring down a server. So, I mean, I'll throw out an example. For example, you have DDoS mitigation facing the internet, and you get someone inside your network launching a LAN attack. At that point, what happens? Well, then now you have to set up security for that as well. So sure, you can protect every single aspect of your network, but at that point, is it worth the cost? Maybe, maybe not.
Thank you, Matt. And Matthew Prince from Cloudflare just joined us. Matt, your opening remarks?
Sorry, I'm late.
Let's go ahead and give a couple.
I was downstairs giving out Nerf guns, so if anyone hasn't had any, we have another 150 that we're saving for tomorrow. So I'm from Cloudflare. We make the internet faster and protect websites from bad guys. We didn't originally start out as a DDoS mitigation company, but it turns out if you put 500,000 customers behind you, occasionally they get attacked. The core value of Cloudflare has always been that it gets smarter the more traffic that passes through the system. And so we learned very, very quickly how to deal with very large attacks. And today, we're out of breath, I ran. We are attacked. I actually don't know that there's any company on earth that sees more DDoS attacks than we do on a minute-by-minute basis. And we've gotten very, very good at stopping them. And so quite different than a lot of other folks, we try to make we try to make it incredibly affordable to actually stop these attacks. Like I see my job as helping you sleep better at night, and you shouldn't have to pay to sleep better at night. And so even our free service offers a very, very robust DDoS mitigation service, and then we have higher tier services that actually have SLAs that get tied to that. So we're trying to really reinvent the market in that sense. So that's what we do, and excited to listen to these guys and hopefully catch my breath.
Thank you, Matt. As we move forward, our questioning is going to be more technical in nature. So I'd like to remind our panelists to make sure that we're speaking of specific vectors, specific technologies that can be, or measures that can be implemented to mitigate attacks, and not so much exactly what appliance or what specific service should be used. Because I'd like everyone in this audience to step away with the knowledge of what can you do for yourselves right now that may or may not require you to put money on the table. My next question is for Dr. Richard Zhao and his focus. Doctor, what synergies exist between enterprise DDoS mitigation systems and enterprise DDoS mitigation service providers, and how should a typical small medium business web host approach DDoS mitigation on behalf of its customers?
Okay. So at the enterprise DDoS mitigation system and the service are two main major approaches in the market. So they, from the technology perspective, they have very common foundation. They can share a lot of best practices to fight against the DDoS attacks. Even they have different business approach to at the processes, at the business models. But there are two major approaches in the market. So even they are different sectors, subsectors in the market, but we believe they can share something to protect the end user. That's the most essential things in the market.
In terms of my bullet point there, I guess my question was along the lines of what's an effective strategy? Should these smaller providers be establishing bastion hosts or relying on a cloud security provider or putting a little bit more money down getting the enterprise solutions provider? How do those work together and how should that decision be approached?
Actually, it's not only a pure technology question, it's a business question. So it's similar to the cloud computing strategy at this moment. Most enterprise CIO should consider for the typical SMB web host, they may consider DIY approach or choose a service provider to make it. It depends the IT operation size and the budget and how critical the service is. In generally, if the enterprise doesn't have in-house IT professional expertise, it's better for them to outsource it to the service provider to get a more professional service. But for the enterprise with very critical security requirements, they may do a hybrid approach. That means they have some in-house professionals working together with the professional service provider and even some on-site appliances. I'm not sure if that answered the question.
I appreciate that. Thank you, Doctor. My next question is for Matthew Prince. Matt, what are some of the challenges that one faces in dealing with layer 7 application attacks? And what commercial solutions are best suited to address these issues? And finally, what can a hosting company's administrator do to combat a layer 7 attack without necessarily relying on any service?
Sure. So again, I don't know what the technical sophistication is of people in the audience. So layer 7 is referring to the OSI model, and layer 7 is the application layer. And so traditionally, denial of service attacks have largely been targeted at layer 3 or layer 4, where they are either trying to fill the entire application, or they're trying to essentially fill the pipe up with either a bunch of garbage SYN traffic or other traffic that comes in. Increasingly, we're seeing layer 7 attacks that are targeting the underlying application, doing things like opening a large number of connections to Apache and not closing them quickly. So like a slow read or the slow LoRa's attack, or various connections that will actually slow things down. And the answer to how you can solve, I mean, there are, again, a lot of different ways that you can solve that. If you want to solve that without relying on a provider in order to solve it, then some of the best things to do are actually go through your stack and think about, in terms of what you're offering to your customers, and think about what applications perform better for these types of attacks. So, for example, if you switch away from a web server like Apache, which every time a connection comes into Apache, there's actually a bit of memory that gets allocated. So at the end of the day, denial of service attacks are all about exhausting some resource or another. And so if Apache is allocating a little bit of memory each time, and you open enough connections, eventually you're going to fill up that entire memory pool, and that will terminate your Apache connections. So a better architected application, so we were friends with the Nginx guys. It will hold up to a lot more connections. It's much more resilient to this type of attack. It's an open source project, and to the extent that you can support that for your customers, that's something that will help mitigate some of these layer 7 types of attacks. The one good news, really good piece of news with layer 7 attacks, is that the identity of the attacker, and I don't mean it's someone in Kazakhstan, I mean the IP address which is coming in isn't forged in those attacks. And so if you can start to build a database of the layer 7 attacks that you're seeing, then over time you can actually use that data in order to mitigate those attacks going forward. And so if you are a provider that's seeing a large number of attacks, logging those attacks, taking that information, and then finding a way to deploy that out to your routing infrastructure can actually help you in the future stop those types of attacks from coming forward. And so that's something that again, since it's the good news is if you're attacking the application, then you've had a full TCP handshake, which means that you've got an authenticated host on the other side, which means that you can then assign a reputation to the IP address of that host, and that reputation can be trusted and followed.
Thank you, Matt. Next question is back to Dr. Richard. Matt Prince discussed the difficulty in mitigating layer 7 attacks. How is this problem intensified when the attack is targeting SSL? And what holistic strategies are effective against a layer 7 SSL attack? And there's a couple of follow-up questions concerning the same as to how the SSL attack mitigation is going to be handled from a privacy compliance standpoint, and what can a small medium business do to defend themselves from this emerging threat?
Yeah, a couple of tough questions. At the IPv6 and the IPsec and SSL world, so it's a challenge for the traditional network security appliances, devices to handle the encrypted packets in a traditional way. So talking about the mitigating layer 7 DDoS attacks with the SS-enabled website, it's a challenge for the architect to design the choke point for all the traffic to going through and choose the appliance with the SSL or IPsec accelerated chips or enhanced devices to make sure the performance of the device won't be a bottleneck of the whole system. As the holistic strategy to fight against the layer 7 attacks, we need to consider not only the layer 7, the TCP IP, but from the whole stack of the system. For example, at the according to our current research at the IPv6, during the about 110 CVE vulnerabilities of IPv6, more than half of them could be exploited to conduct the DDoS attacks. So it's a challenge to adopt IPv6 and make sure all the network devices along the critical path are equipped with the latest version of the software to remove all the vulnerabilities. This is one aspect to mitigate, to fight against the layer 7 SSL attack, while we need to tune all the parameters along the critical path, including the switch, the routers, and the servers. This is also very important, but it requires very deep expertise for those parameters, and maybe the general administrator need to work together with the security experts on this domain. As for the third question, is the privacy compliant perspective. That's related to the first question. So that means from the architecture perspective, in general, the encrypted packets need to be decrypted and do the general security check and re-encrypted and repacked into the stream. So this brings challenges for the compliance requirement, for example, PCI DSS. That means in the middle, in the choking point or the IPsec checking point, needed to protect this point at the full stack.
So, Doctor, what you're stating is that under a SSL attack at layer 7, those packets have to be decrypted, and that brings new concerns for compliance in PCI.
Yeah, in order to inspect the packets, they need to decrypt. So this gives a chance for the attackers to penetrate into this server or this device and get the data. So this becomes a bottleneck or the shortest one in the security chain.
So not only is it a difficult challenge, but in the process of decryption, you could actually be opening yourself up to additional regulatory concerns.
Yes.
All right, thank you, Doctor.
Do you mind if I add something?
Go ahead, Carlos.
Now, I've had the opportunity to talk to a few CSOs from some of the major banks, and frankly, especially from a PCI compliance, which is the primary one that has this implication because of the banking industry and SSL and credit card information. There's a lot of disagreement over what the PCI compliance actually states and or dictates. Some of them say that you cannot decrypt the packets anywhere other than in the final server that's actually terminating the messages. Other CSOs of, again, major banks are saying, no, while you're within the same data center, you can decrypt the packets, do what you need to do and do it. I prefer the latter implication because it actually gives you an opportunity to do something from a security perspective. And it seems that the law on this, or the compliance law isn't completely let's say, explicit on it. So I think in a lot of cases you can kind of work with your customers and with the banking auditors that they deal with to determine what the best thing to do. Frankly, from a security perspective, the only solution is to decrypt, look at the packet, do the work on it, then re-encrypt it.
Thank you, Carlos. Next question is for Matt Mavi on behalf of Kevin Hatfield. Matt Mavi, again, Staminus Communications. Discuss how a hosting provider's system administrator would secure a Linux system to protect against DDoS attacks, and what limitations exist when using a single server or bastion host as an availability security practice, and what additional implications exist when using Windows.
All right, so I'm going to open up with saying don't run Windows if you want to stay up against DOS attacks. It's not going to work. It's never going to work. You're not going to get it to work. Now, on a single server, how much time you guys got? We can run through a lot of commands, but basically at the end of the day, when you want to secure a single Linux box, you're talking about a whole bunch of stuff. A lot of real simple stuff, block out ports you don't need. So if you don't need port 443, why do you have it open? Block it out. Block out every single port you don't need. Then you probably want to turn on things like SYN cookies. So let's say on Linux, you turn on SYN cookies, that's going to protect you a lot from just like half-open SYN connection. When they send a SYN, you send a cookie out, it's got to respond with an ACK. You can do a lot more with IP tables and a lot more complicated firewalls. So if anybody here has ever used IP tables, you go into like hash limits and recent matches, a lot more complex matches like that. And you can put together something really simple in under 30 lines and make it work really well. You can go into even more detail than that. You can actually run user space apps to dump the traffic using Linux socket filters, for example, and extract that traffic, look at that data, and drop it into, let's say, an IP set to block the traffic that you detect to be bad. One thing you guys never want to run is you never want to run a whole bunch of IP tables because it is a sequential algorithm. So you're going to run like 100 rules in there, and you're going to run 50,000 packets a second through it. It's going to bring the box to a halt, even if you're blocking stuff. So there's stuff you can do with a single server to really block a lot of traffic. You can look at hardware, for example. I mean, you don't want to run Broadcom NICs. You want to run Intel NICs. Something where the IRQ doesn't destroy it. Something that's running NAPI. Something that's running some kind of IRQ throttling. So a lot of little technical details that go into this. A lot of this stuff Windows just does not have, and you just really can't do much with Windows. So I guess that's really it. I mean, there's a lot that you can do, but at the end of the day, your limitation is going to be the performance of the single server to handle both the end user load and the mitigation that you're going to be doing. So let's say you want to mitigate, 50,000 packets a second. You can drop Nginx in front of Apache, and that'll possibly take 50,000 with some IP tables rules. But anything over that, you're talking about, at that point, let's say 100 meg ports limitation at about like 150,000 packets a second, depending on the packet sizes. Even on a gigabit port, you're really not going to be picking up a lot more bad traffic because you just don't have enough CPU. So let's say you throw in like a dual hex core, sure, now you have some more CPU to handle that, but at what point do you then throw an extra server in front of it to dedicate the processing?
Thank you, Matt.
So just to put a fine point on it, I think that's all exactly right. The combination that we've seen that gives us the best performance, and the best that we've gotten to is on a single server with a 10 gig NIC, and again, the cards that we've seen that get the best performance by far are solar flare cards, which is primarily, they're in a high frequency trading space, and they have really big buffers in them. So we can get about 1.5 million packets per second on a box with a 10 gig NIC. And essentially the Linux configured that way. You can actually get slightly higher performance per second if you use some of the BSD variants, because their network stack, the way that it pulls against the network card, can get you actually slightly higher performance than that. But 1.5 million packets per second on a single Linux box is pretty good. And the solar flare cards are getting cheap enough that certainly for some scrubbing boxes, they can make a lot of sense.
Thank you, Matt.
Can I actually ask another thing? So on those, are you actually servicing HTTP at 1.5 million a second, or are you servicing SYN packets?
So it's that's SYN, it's SYN packets. So that's the packets to do that, to get that back to you. I We don't have any of that in production to do. This is all kind of labs stuff for us. But our next generation hardware will be out at probably around that, and it will be less than 1.5 million.
You might actually be able to achieve that if you're just doing blocking. You can actually achieve over 1 million packets a second on a gigabit Intel NIC. So you don't even need to go into 10 gigabits. So Linux and BSC can all block at line rate. But it really becomes more complicated when you get into layer 7. That's really where the majority of attacks are.
All right, thank you, gentlemen. Let's keep moving so we can make sure that we have time to get to the audience questions. Carlos, this question is for you. What is the role of on-premise DDoS mitigation systems, and when should a web hosting provider consider making that purchase? And are there instances where other solutions may be more appropriate?
Okay, so I guess the first thing you have to consider is what is your business, and what's the import of the internet on your business, right? So as a case in point, right, a lot of people invest a lot of money in fire extinguishers for the purposes of keeping the availability of a data center from, you don't want it to burn down, therefore you're not available. Very similarly, DDoS is a threat to availability of your internet services, right? So if a DDoS happens, and it's a likely case with the likes of Anonymous and other vigilante groups that will drop a DDoS attack on you for insulting whatever on Facebook, you have to then figure out, okay, what is the subsequent impact on my business from a monetary perspective? If I sell stuff online, if I'm a retail provider, it's a pretty significant impact. For every minute of downtime, let's say, for instance, you're Amazon.com or you're XYZ.com. For every minute of downtime, it's lost revenue. It's customer churn, it's that. So the primary consideration when you start looking at whether or not you want DDoS defense is, what is the impact of your business for an outage? Okay, great. So we've established that DDoS is impactful to me. If I have an outage, it's going to cost me X, and that's going to dictate what you might have as a solution, or what you might be able to consider as a solution. The next step really is to determine how big is your bandwidth. What's your overhead bandwidth? Meaning, I have a gig link and I run 100 meg. Okay, great. You have some amount of bandwidth to withstand a DDoS attack. Or I have a 50 meg link and I've got a 50 meg link and I'm running 45 meg at peak. Well, you don't have a lot of bandwidth for DDoS. So I would say that the higher amount of shunt bandwidth, or the amount of excess bandwidth that you have on your prem, makes it more likely that you're going to have success with some type of on-prem DDoS solution as a solution. If you don't have the overhead, you don't have the bandwidth, then you really have to look towards your upstream providers who have bigger pipes, who can withstand a larger attack to do that. And I'll say this throughout, but DDoS itself is an ecosystem, because even if you have huge pipes, there's a botnet out there that can take you down. I don't care if you're 100 gigs worth of internet bandwidth. Well, I've seen a 250 gig attack. So that in and of itself is not, or having a prem solution isn't an end to a means of itself. So you have to look at how much you have, whether or not on-prem makes sense given that, and then look to having some type of upstream provider to help you with it if you don't.
Carlos, so if I'm understanding you correctly,
Sure.
as an ecosystem, there's multiple different solutions. So an on-premise system is one part of that ecosystem. Then maybe the cloud security provider is another part of that ecosystem, or perhaps the enterprise DDoS solution. And when you string it all together, it provides that holistic defense in depth.
Correct. Yeah. So you got to look at it like you have locks on your doors. You do stuff locally at your house, right, to protect your house. You have a neighborhood watch. That's kind of a broader, the cloud service provider, and you have maybe the police force. That's the enterprise-based carrier solution, right? You want to have multiple layers of depth for the type of threat that might come at you.
Great. Thank you. And here is your supporting graphic, Carlos.
Yeah, this sort of shows a little bit of what I meant by ecosystem, right? So presumably most of you guys, or all of you guys, are hosting providers, which means that you have a bunch of customers behind you, you have some amount of bandwidth to the internet. Depending on the size of that bandwidth, it makes sense for you guys to have something that you can offer to your customers as a value-added solution on your own prem, something you guys could run and and provide deeper and it may be services to your customers to protect them from threats. The less bandwidth you have, and/or even if you have a lot of bandwidth, there's a need to actually work with people who have bigger bandwidth. You know, the AT&T, the Verizons, or the Black Lotuses of the world, right? That have more bandwidth at their disposal to be able to take that DDoS attack and not have it actually even hit your data center. So the only real solution to this problem is to have an ecosystem in place that would include on-prem if it makes sense, and some type of upstream help.
Thank you, Carlos.
May I add one?
Go ahead, Doctor.
The anti-DDoS technology of the devices is much more dynamic than the traditional firewall. Actually, it's more close to the IPS or IDS system. That means it should be updated very promptly according to the latest threats. That means the security intelligence and the research team with 24/7 responsiveness is very critical for the effectiveness of the anti-DDoS system or services. So this is also the key part of the ecosystem just mentioned.
Thank you, Doctor.
I would absolutely agree with that. I think that that's a strong consideration when you choose the technology and/or the upstream provider that you work with is not only what they have, how much can they process, but what expertise they have in the area, what they have, how often they actually mitigate attacks, what type of research capabilities do they have? Do they have subscriber reputation capabilities like what these gentlemen have already spoken of? So those are definitely strong considerations as you're choosing a product or a service.
Thank you, Carlos. We're becoming low on time, and I want to make sure that we have enough time to speak with the audience and get the answers to the questions that are important to you all. So I'm going to wrap up with one question that I'm going to direct to Matt Prince at Cloudflare. Matt, cloud mitigation solutions are becoming increasingly popular, as you're well aware. Where do these solutions fit in an administrator's toolbox? When is it and when is it not appropriate to use cloud mitigation? And are there instances where self-defense tactics or the on-premise hardware may be a more appropriate solution?
So I think that of all the security challenges, DDoS mitigation is the one that if you were only going to do one thing or the other, it makes the most sense to do from the cloud as opposed to doing on-premise. And this would be we can all fight about this later. The reason why are twofold. The first is that in the cloud, again, DDoS is all about resource exhaustion. And so however large your connection to the internet is, we are able to do some things that you're just not able to do. The first is that we can use something like Anycast, which is a technology that allows us to distribute, or any cloud provider, to distribute load across many, many, many different systems. So every one of the data centers that someone like we run or Prolexic or other large cloud providers will announce the exact same IP set. And so if you have a big botnet, instead of us having to deal with the entire botnet hitting one router somewhere, we have that to deal with that hitting 23 different routers scattered fairly evenly across the world. So, for example, in our case, we're building POPs in China, not so much to service the Chinese market, but to be black holes where when attacks come out of China, they hit there and they just stay there. And that's a huge solution to problems like that. That's the one thing, and that's very easy to understand in terms of you just have more resources that are spread across more clients if you're in the cloud. The piece that is less obvious is that the way to solve this, the problem with the security industry generally is that we all